Hello everyone, welcome back to my channel. My name is Israel and I am a lead DevOps engineer. In this channel, you're going to be learning a lot of things regarding DevOps, and all of these are drawn from my own personal experience as a lead engineer. In today's video, we're going to be learning something about the Kubernetes Ingress and the Gateway API. For the past few months and few weeks, we've been hearing a lot of informations regarding the Gateway API. One of the major reasons is because the Nginx Ingress controller is getting deprecated, and that has actually sparkled a lot of concern when it comes to the Kubernetes Ingress. The Nginx Ingress controller is just one of the Ingress controllers, right? We have different kinds of Ingress controllers. We have Nginx, which is the one getting deprecated. We have Kong, we have HA proxy, we have Istio, we have ALB. There are so many Ingress controllers, but in this video, I want you guys to understand the difference, the core difference between an Ingress and a Gateway API. Now, both of them aim to solve the same problem, which is to expose our application to external user. The Ingress does that, the Gateway API does that, but the Ingress controller comes with a lot of limitation. But before then, if you've not subscribed to my channel, support me by subscribing to my channel. Let's jump straight into it. Before we explore the Kubernetes Gateway API, let's understand how the Kubernetes Ingress works. Because if we don't understand how the Kubernetes Ingress works, we wouldn't appreciate the beauty or the additional functionality that the Gateway API is here to provide for us. So Kubernetes Ingress is the native way of exposing application in our cluster to external users. How does Kubernetes Ingress work? In a Kubernetes environment, when you want to use a Kubernetes Ingress, you need to install an Ingress controller. If you don't install an Ingress controller, but you create an Ingress resource, then that Ingress resource is not going to work. Simply because it is the Ingress controller that does the logic, that does the routing. So what is an Ingress controller? In a simple word, an Ingress controller is simply a load balancer or a reverse proxy. Now let's take an example. Now, let's say this is a Kubernetes cluster and we have the user accessing your application. Now, at the right-hand side, we have the two applications running inside a pod, and those applications are targeted by a service type of cluster IP. How do we access this application? First of all, the Kubernetes administrator needs to install the Ingress controller. Now, this is the Ingress controller here. In this case, we are using Nginx as the Ingress controller. And once the Ingress controller is installed, you need to create an Ingress resource. An Ingress resource is the manifest file. It is a resource that tells the Ingress controller how to route the request. Now, this is how a typical flow looks like. When a user hits the load balancer, which is the external load balancer provisioned by this Ingress controller, the entire packet is being routed to the Ingress controller. Now, your Ingress controller evaluates the rules, and based on the rules, the host, and the path, it makes an informed decision to reroute the traffic to the service and from the service to the pod. Now, mind you, your Ingress controller is also a load balancer or a reverse proxy. Now, you might want to ask, why do we now have two load balancers? If you look at it very well, your Ingress controller or the reverse proxy running in your Kubernetes environment is inside your cluster, which means that nobody from the outside world can access it. So it doesn't make any sense, right? So in order for you to be able to access this load balancer, you need to expose it. And how do we expose application inside a Kubernetes cluster without using Ingress? You need to use a service type of a load balancer. So most times when you install an Ingress controller, under the hood, the Ingress controller is going to provision a service type of load balancer based on where your Kubernetes is running on. If it's running in a cloud, your cloud provider is going to provision a load balancer that is tied to that service. Mind you, that load balancer provisioned by your cloud provider is a layer 4 load balancer, which means that load balancer does not understand application level details. So what happened is that layer 4 load balancer simply just pass all the traffic from the outside world to the main load balancer, which is going to make the informed decision on how to route your application. Now, we need this layer 4 load balancer or this external load balancer because we need an endpoint, right? We want to point our application or the host to a particular load balancer or to a particular endpoint. Otherwise, we won't be able to hit the Ingress controller. I need you to understand that the main thing that does the magic here, it is the Ingress controller, which is inside your cluster. So the whole idea of us provisioning a load balancer outside is just for us to be able to access the main load balancer inside the cluster. For load balancer operates at the layer 4 of the OSI model, which means that it understands TCP and UDP, and it is owned by the cloud provider, right? So if you are running it on EKS, Kubernetes, if you are running on EKS, Amazon is going to provision a layer 4 or network load balancer for you. And that load balancer is going to have an IP, it's going to have a DNS, it accepts traffic, forward traffic, and etc. Now, when you want to access your application, you simply create a CNAME record or an A record pointing the host name of your application to this load balancer. So that when user want to access your application, the host name is resolved to the IP address of this load balancer, and the entire packet is passed to the main load balancer here. So this load balancer only routes requests based on IP and port, and everything goes straight. And I also need to understand that before this Ingress controller, which is a load balancer, can route traffic to your service, there needs to be a TLS termination to be able to decrypt the traffic. Otherwise, if the traffic is encrypted end to end without a TLS termination at this point, that means your application, that means your load balancer wouldn't be able to see the packet, neither route the traffic to the backend service. So in a nutshell, your Ingress controller does the routing. Number 2, it does TLS termination. Number 3, it does host-based routing. So depending on the host, it's going to route the traffic to the service and from the service to the pod. And also, it also routes based on path. Now, based on the path, it can also route traffic to a certain service and then to your pod. Now, before we go forward, then I need you to understand a second implementation of this. Now, if you are using EKS, that architecture somehow changes a little bit. So if you are using Ingress control, if you are using EKS, we're using an ALB Ingress controller. Now, an ALB Ingress controller already understands layer 7 protocol, which means that when the traffic hits it, it can make the decision based on the host and path directly to the service and from the service to the pod. So in this case, the load balancer is already running externally because this load balancer is from the cloud, right? It's from AWS or EKS, which means that it is not running inside the cluster. So because of that, we already have an external endpoint on how we can route traffic to our back-end service or to our pods. So what happened is that when you create an Ingress resource, when you create an Ingress resource, when you state the Ingress class need to be ALB, it means that Ingress resource is going to provision a load balancer. So that endpoint of the load balancer is what your user can hit in order to access your application. So we have different kinds of Kubernetes Ingress controller implementation. We have loads of them. We have Nginx, we have traffic, we have HA proxy, we have Kong, Istio, etc., etc. These are all implementation. Now, what are the limitations of the Kubernetes Ingress? Now, we've seen that the Kubernetes Ingress primarily route traffic based on the host and path. But we all know that in a production system, routing based on just the host and the path is not just enough. You might want to route your request based on HTTP headers or HTTP method like get, post, pass, put, or you want to filter traffic based on request parameters. Maybe carry out A and B testing or even canary deployment, whereby you want to route traffic to some certain users. Maybe you want to route some certain percentage of your traffic to version 1 of your application and 60% to the version 2. Now, all these are different kinds of deployment strategy. But with the Kubernetes Ingress, all of these does not come natively. Now, if you look at the Kubernetes YAML here of the Ingress, the spec section of the Ingress, you can only route traffic based on the host and path. Now, in this case, this host is service-a.example.com. And if the traffic is coming and it matches the path/test path, that traffic is routed to the service A, which is going to redirect it to the backend port. It means that we can't do much with the Kubernetes Ingress. There's little we can do with the Kubernetes Ingress. It does not support TCP and UDP. It only supports layer 7, which is HTTP and HTTPS. Most of the production features are not supported primarily by the Ingress. And because of that, we now see so many companies trying to, bypass that limitation by adding annotations. Now, if you look at it very well, you can see annotations here, whereby different implementation like engines, traffic, all of these Ingress controllers have their own annotations. So whenever they want your Ingress to behave in some certain way, they just simply create an annotation for that Ingress resource. Now you can see that with engines, if you want to carry out TLS or SSL redirect, you need to add this annotation to your Ingress resource. And also, if you want to carry out rate limiting, you also need to add these annotations. You want to verify TLS or mutual TLS, you need to add all of these annotations, and so forth and so forth. Now, if you look at it very well, if you look at this Kubernetes manifest for Ingress and this one over here, you will see that this one is a little bit messy. It contains a lot of information. Now, as if that was not enough, if you want to change from this Ingress, if you want to change from this Ingress controller to another Ingress, let's say you want to migrate from Nginx to traffic, it means that you need to rewrite all of this annotation to match the new Ingress controller implementation. And that is a huge overhead and it is not scalable. This is Ingress. This is just Nginx Ingress annotation. If you go online and search for AWS load balancer controller annotation, you're going to see loads of them. If you search for HA proxy annotations, you're going to see loads of them. And all of these are different across all implementation. That is the major drawback of the Kubernetes Ingress. Just a recap, the Kubernetes Ingress natively, Kubernetes only support what is inside the spec session. And if you look at it very well, the spec session contains fewer things, which is the host and the path. This is actually what determines how to route your traffic. Now, because production systems require more than this, you will now see that many companies are now trying to create a way or making the Ingress behave in some certain way by adding annotations. And all of these annotations made the Ingress resource over complicated. Now, all of these limitations are what the Gateway API comes to solve. Now, let's have a look at the Gateway API. Now, the Gateway API standardizes all the routing implementation, so you don't have to use annotation per implementation. And secondly, the Gateway API uses CRODs. Now, let's understand how the Gateway API works. First of all, for you to use the Gateway API, you need to install a Gateway API controller. Like we have different kinds of Ingress controller, we also have Gateway API controller. We have Cilium, we have Istio, we have Envoy, we have Kgate, we have Traffic. There are a lot of them in the market, and you can choose anyone based on your specification. How does the Gateway API solve this problem? Now, the Gateway API divided all the resources into 3 different classes. Number 1, the gateway class. Number 2, the gateway. And number 3, the route. Now, the gateway class is a specific implementation of the Gateway API. For instance, when you install a Cilium gateway controller, under the hood is going to create a gateway class for Cilium. Same for Istio, same for Envoy. So it means that when you want to use Gateway API, the first thing you need to do is to install the Gateway API controller. And that Gateway API controller is going to provision the gateway class. Now, what is a gateway? Now, mind you, I've said it before. A gateway class is just an implementation of the Gateway API. It is those, we have Cilium, we have Istio. So those are the gateway class. And the gateway class references the controller that will implement the gateway. It usually comes installed when the gateway controller is installed. Similar to storage class, ingress class, and must have one gateway class in the cluster. Now, the second one is the gateway. Now, the gateway is the proxy that does the load balancing or that does the routing. Now, the gateway is just like an entry point that actually does the routing. It is just like at the front end of the cluster. So when traffic wants to come to your pod, it needs to go through the gateway. And based on what you specify in your gateway, maybe you specify a port of 80 and 443 as the listening port, right? The traffic is going to hit that port, and based on your routing decision, it goes straight to your port. And that brings us to the next one, which is route or HTTP route. Now, the gateway is like your Ingress controller, and then your route is like your Ingress resource. Now, if that's confusing, don't worry. So let's say that the Gateway API is the entrance into the cluster, but the route is the decision or the logic or how you want to route that request. Now, so this is how it works. So when you provision a gateway, your gateway is going to reference a specific gateway class. Now, first of all, you need to create a gateway class. And your gateway class is going to reference a gateway controller, right? This is the gateway controller. Now, after that, so when you create a gateway class, it's going to have a controller name. Just like I have explained, when you install your Gateway API controller, out of the box, it's going to provision this for you. So most times you don't need to create a gateway class, because your Ingress, by installing the Gateway API controller, this already come out of the box. But then you need to create a gateway. Now, you create a gateway by specifying a gateway class. As you can see, this particular gateway is referencing this particular gateway class, which means that it is the gateway class implementation that is going to be used for this gateway. Now, once you've created your gateway, the next thing you need to create is your HTTP route or your route. Now, your route is also going to reference the gateway. So like I said, the gateway is the entrance into the cluster, and your HTTP route tells the traffic or the packet how or where to be routed to. So your HTTP route is going to reference your gateway, and also it's also going to reference the backend service. And then once the traffic comes, evaluate it, and then it routes it to the backend port, either of these two service backend port. As you can see, backend reference example service, which is going to reference this service, and example service canary is going to reference this one. And as you all know, the service is going to send the traffic to the ports. So this is the cluster. we have a gateway already provisioned inside the cluster. Let's say that it is running on the platform namespace. This gateway is going to reference a gateway API controller. Now, the gateway API controller already creates a gateway class. Now, that gateway class is going to be referenced on this gateway. So this gateway is pointed towards the Cilium gateway class. So when the traffic comes, it's going to hit this load balancer. Now, when you create a gateway, your gateway under the hood is going to create a load balancer, which is the endpoint to access this gateway. Now, how does the gateway create that? When you create a gateway is going to provision a service type of a load balancer, and that service type is going to provision a load balancer in your cloud environment. So user is going to hit it and it's going to resolve to the gateway. Now, if you look at the gateway very well, we have listener, which is running on port 80. It means that in order for you to hit the target on this gateway, the load balancer, you need to hit port 80 of the load balancer, which is what exposes your gateway. Now, after your gateway, you also need your HTTP route. Now, your HTTP route is going to live in the same namespace where your application is running on. And your HTTP route is going to refresh your gateway. So when the traffic comes, it hits the gateway, and based on the rules stated here in your gateway, it's not going to redirect the traffic to the service. Mind you, the HTTP route here is just a logical resource here. It is not actually a physical resource. So sometimes I tend to group it together with the gateway because this HTTP route is referencing this gateway, which means that when the traffic comes to the gateway is going to evaluate all the HTTP route inside and then make decision. But for simplicity case, I decided to just leave it here on this workload namespace. So the HTTP route references this gateway. So this gateway sends the traffic, by passing through the HTTP route. Now, the HTTP route contains the routing rules, right? If you look at this very well, these are the routing rules. It's going to mash /login. It's going to send to backend pods. So the routing rules is going to be evaluated. And from the routing rules, we see that we want to route 80% of the traffic to the first version of the application, which is version 1. As you can see here, we want to route 80%. And also we want to route 20% to the other application. And that is exactly what we see here. We can see that we are routing based on traffic and all of that. Now, it goes to the service, from the service to the 2 backend pods, likewise the other one. So you can see that all of this feature comes out of the box using the Gateway API. Now, in order for you to achieve this using Ingress, you need to add a lot of annotation. You need to add so many annotations, and that is the greatest limitation of the Ingress resource. And that is why the Gateway API was born. And mind you, this is just one use case of the Gateway API. There are so many things that you can do. Now, a rule of thumb is all those things that you can do using annotation on Ingress, the Gateway API have them as a normal implementation. So you don't need to start adding annotation. It comes out of the box with the Gateway API. So just a recap, the Gateway API, in order for the Gateway API to work, you need to install a Gateway API controller. Now that Gateway API controller is going to create a gateway class for you, just like you have an Ingress class when you install Ingress Controller of Nginx. So that Ingress class is what you cannot reference on your gateway resource. Now your gateway resource is going to create a load balancer, which is what we are seeing here. So if you provision these on your cluster, let's say you are running it on EKS, it's going to provision a network load balancer for you. And ensure that your gateway is referencing the correct gateway class. So if you have 2 Gateway API class on your cluster and you want one particular gateway or you want one particular gateway API to handle the implementation, you need to reference that class on your gateway. And your HTTP route also need to reference that gateway. So from there, you can now route your traffic. Now, so in our next video, we're going to be doing some hands-on on how we can deploy application and migrate from Ingress to Gateway API. If you are curious to learn, you want to understand how to implement this in your Kubernetes cluster, please subscribe so you can get notified when that video is published. For the meantime, please do well to follow me across all social media, and thank you so much for watching this video to the end. If you have any question, please, you can leave it in the comment section below and I will be sure to read them and also to get back to you. See you in the next video.